Hi, Anthony Carruthers, Better Lesson, Master Teacher Project. And here I'm explaining how we review properties of the perpendicular bisector and the angle bisector in preparation for constructing the circumscribed and inscribed circles of a triangle. So this is a demonstration that I would typically do for the students. And here I'm just explaining what that demonstration is like. So we'd start off with a segment such as this. And I want to construct the perpendicular bisector of that segment. So I'm going to construct the midpoint, and I'm using Sketchpad here. And through that midpoint, I want to construct a perpendicular line. Okay, so as you can see, we've created the perpendicular bisector. I'll just make some notations to it to make it clear that it's the perpendicular bisector. And I'm choosing now an arbitrary point that's on the perpendicular bisector. So looks like I can move that up and down. So what I'll do is measure the distance from that point to this endpoint, and also measure the distance from this point to the other endpoint of the segment. So as we know, those are going to come out the same. That's what the perpendicular bisector theorem tells us. And then I would just want to show students that no matter where on the perpendicular bisector we move the point, that point will always be equidistant from the endpoints of the segment. So at that point, I just have students do some pair share to make sure they're processing what they just saw and that they have it written down somewhere as a reference. This is not new to students, it's actually review, but since they'll need it for today's constructions, I want to make sure that it's fresh in their mind. Okay, so then now I move on to a new sketch, and this sketch will involve the angle bisector. So for that, I'm going to need an angle. So I'm going to grab the ray tool, and so I have one ray, and then let's have another ray. Okay, and then once I have the angle, I'm going to create the angle bisector. Okay, now what we know about the angle bisector is that any point that's on the angle bisector should be equidistant from the sides of the angle. So at this point, I need to emphasize to students that when we say the distance from a point to a side, we have to talk about the perpendicular distance. So here I would select this segment and this point and construct a perpendicular. Okay, so when I measure the distance, actually I'm measuring the distance from the point to this intersection of the perpendicular and the other side of the angle. So similarly, I would want to construct the perpendicular from this point to this side of the angle. So I'll construct that perpendicular as well. And then I'll want to clean this picture up so that we can show actually the distances that we're measuring. So now I'll get rid of those perpendiculars once I have their intersections. Okay, so I just want to hide these perpendiculars. Okay, and in their place, I'll draw the segments that basically indicate the lengths that we'll be finding. And to emphasize to students again that these are the perpendicular distances, I'm going to show how we would label those angles, although that one's not cooperating. So we'll see that that's a 90-degree angle and that this should also be a 90-degree angle. Okay, so in any case, I want to measure both of these distances. Okay, we see that they're both 5.3, and no matter where on the perpendicular bisector, the angle bisector, I place that point, that distance is always the perpendicular distance, and this point is always equidistant to the sides of the angle. So again, I have students pair share just to make sure they're processing this, that they have it taken down their notes so that they're clear on it when it's time to do the constructions of the circumscribed and inscribed circles of a triangle. Once again, Anthony Carruthers, Better Lesson, Master Teacher Project.